Hello everybody, in this video we're going to dive into the inner workings of mass spectrometers. We're going to focus on the Sci-X Triple Quad 5500 MS. We'll go through the various parts throughout the instrument from beginning to end, and finally look at a mass spectrum. To begin, mass spectrometers are expensive pieces of equipment used in analytical chemistry, which is applied in many different fields. The device is capable of detecting very trace amounts of molecules, which makes it ideal for various environmental testing and research in life science and clinical settings. Additionally, mass spectrometers deliver high levels of sensitivity, making them a key component in pharma and biopharma domains, as well as food and beverage testing. Mass spectrometers are often coupled with high-pressure liquid chromatography or gas chromatography devices, but for the purpose of this video, we'll stick with the MS itself. Now, the first step in utilizing the device is to prepare your sample. The sample should be very dilute. We're talking micromoles per milliliter. We don't need a lot of the sample, simply because of how powerful the machine is. On the right side of the front of the MS, you'll find a place to input the sample. The sample should be located in a syringe, the needle attached to a very thin tube, the other end of which is connected to the machine, and placed in the syringe pump. The machine will input the sample at a very low rate, just about 5 microliters per minute. The sample is then fed into a very high energy electrode where it becomes vaporized. The electrode itself is a long, thin needle. Once the sample reaches the end, you can see the electrospray being emitted and pulled back into the machine. At this point, the sample exists as an ion. To ensure minimum contamination, the machine will require a stream of inert gas, such as nitrogen, to be fed behind the electrode. The ions are now in the first quadrupole. If you remember back to the beginning of the video, this MX is the Sci-X Triple Quad, meaning there are 3 quadrupoles in the machine. A quadrupole is a set of 4 solid rods arranged to direct the ion beam. An electrostatic field is generated in the space between the rods, and in a given field, only specific ions will make it through. The ions that do make it through are then focused before they enter the second quadrupole. The second quadrupole simply sorts ions. If only the first 2 quadrupoles in the machine are being used, you'll obtain a mass spectrum of the ionized whole molecule from the sample. For example, if I was using the compound methyl orange, I would see a mass spectrum with a high intensity peak at the mass to charge ratio of 304 Dalton, which is the molar mass of the methyl orange compound. On the mass spectrum, you'll also see less intense peaks as well. These are a result of elemental isotopes and impurities from the sample. A common example is to see peaks 23 and 39 Dalton higher than the molar mass of the compound because of the presence of sodium and potassium ions respectively. Now let's get back to the machine. If the sample were to continue on to the third quadrupole, it would first have to pass through the collision chamber. In the collision cell, the internal energy of the ion is increased through collisions with the gas. Remember those nitrogen atoms we were putting in the beginning? The internal energy becomes so high that the molecular bonds break within the compound, producing ion fragments. Those fragments pass through the third quadrupole and into the detector plate, where they become and create an electric current. Depending on how the individual ion fragments interact with the current, their paths will become slightly askew while they bombard the detector plate. The system then gathers the data and produces another mass spectrum showing the intensity of each fragment. If we go back to our methyl orange example, we see 3 peaks on the mass spectrum. The first peak at 289 Dalton, which is the methyl orange compound where a methyl group was broken off. The second peak is at 240 Dalton, another parent molecule fragment where a few sulfur and oxygens were broken off. And finally, at 156 Dalton, we have a fragment of a benzene ring with the sulfite ion still attached. Mass spectrometers are important devices in analytical chemistry as they assist in putting together pieces of a larger puzzle. The device itself, however, is useless if not for the interpretation of the data. The chemist must have knowledge on how to operate the machine, but the real findings result from the reading and interpretation of the mass spectrums developed.